Hi kiddos, Mrs. Avedian here. I'm going to go over what you are expected to do for math on November 8th, 2021, which is today, and it is a Monday, the first day that we're going to be working at home for this next 2 weeks. This is the first page of your math packet here. This is Eureka Math, Module 3, Lesson 3, Writing Products as Sums and Sums as Products. So we have a couple of examples we're going to do. Then I'm going to ask you in some places to pause the video so that you can try out a few problems on your own. And I'll be posting here on my YouTube channel each day the example videos to help you get started. So our opening exercise, solve the problem using a tape diagram. So a tape diagram is like little rectangular boxes that are attached together. So this would be a tape. A sum of money was shared between George and Benjamin in a ratio of 3 to 4. If the sum of money was $56, how much did George get? So we're going to draw a tape diagram to help us solve this. So if the ratio is 3 to 4, first we're going to draw a tape. That's a large rectangle. And we're going to split it into 3 equal pieces. Do your best to try to get as equal as you can. And George's name comes first, so the 3 pieces is George. Now we're going to draw Benjamin's, and we're going to start by drawing it the same exact size. And just pretend like these are equal. Sometimes I'm not as perfect at my equals. But it's 3 to 4, so he needs one more box that is approximately the same size as all the others. And this is Benjamin. And because Benjamin is the second name, I know Benjamin has the 4. He has 3 parts for every 4 that George has. Okay. If the sum of money was $56, how much did George get? So we're being told right now that the sum, so both of these put together, is $56. And we need to figure out how much George got. I'm going to circle that right now because that's the biggest problem with a lot of math lessons is that students forget what's being asked. So we need to figure out how much George has, and we have 1, 2, 3, 4, 5, 6, 7 portions that this 56 is broken up into. We need to find out how much each of these boxes is worth. So if we have 7 units total, each box is 1 unit, and we know that there are $56 total, we need to figure out what 1 unit is. So 7 units is the whole $56. So I'm going to figure that out with division. I'm going to take my 56. I'm going to divide it by the 7 units that we have total. And we will discover 56 divided by 7 is 8. If you need to use a calculator for 56 divided by 7, that's fine. That's fine. The point is for you to learn how to solve these questions, and we're going to, in this module, learn how to solve them algebraically. So sometimes we will need a calculator. So each of these units is $8. How much did George get? George got 3 of those 8 units, or 3 of those 7 units. 3 times 8 is 24. So George got $24. How much did George get? George got $24. Okay? So there's our opening exercise, and we're using tape diagrams. This is really just to connect us to things we've done before and in past grade levels using tape diagrams. So when we see examples like this, don't think that this is just going to be, what you've seen before exactly when you see 3 plus 2 and you're like, why am I putting that in a tape diagram? I know what 3 plus 2 is. I don't need a tape diagram for that. This isn't about learning how to add 3 and 2. This is about how we can use the same models that we used when we learned addition and apply them to variables, which is a letter representing a number that we don't know yet. So it says represent 3 plus 2 using a tape diagram. I'm going to represent this. So 3 plus 2, I've got 3 boxes. I want to make sure that they're equal in size to the best of my ability. And then I've got, so here's my 3 boxes. And I need to add 2 more boxes to it. Here's my 2 boxes. Okay, so that's representing it using a tape diagram. And this is 5 total, but that's not really what we're worrying about right this minute. Right now, I just want you to draw the tape diagram. And on this next one down here, you're being asked to represent x plus 2 using a tape diagram. We do not know what x is. It's a number that we do not know yet. So I want you to draw the x to be a decent sized box here, and then we're adding 2 units to it. So this is our x, and this is our 2. Okay, we don't know how much the x is. Now, if we wanted to, we could try to kind of figure it out. I mean, like, by shape, I drew this x to be about 1, 2, 3, 4. I'm guessing between 5 and 6 would be the length of this x, but that's not what's important right now. It's just showing you how to represent these problems using the tape diagram. Let's go ahead and move on to the next page. On the next page, at the top, it says draw a rectangular array. So a tape diagram is just it's just a line. Think of it as a long, skinny rectangle, that represents an amount. A rectangle is 2-dimensional. It's 2-dimensional. So if we have a rectangular array, you might remember it from lower grades of math where we showed a rectangle. Let's pretend like this rectangle is 2 by 4. And we said the area of this rectangle equaled 2 times 4. We're doing the same kind of thing here, but we're using more than one number. So we've got a rectangle. And on one side, so we have 3 units. I'm going to try to split this up into 3 pieces to represent my 3 units. So this is my 3 over here. And the other direction, I want to have, says I need 3 plus 2. So I need to try to split this into 3. So there's my 3 plus 2 more. Okay. So there's my 3 plus 2 over here. Now we're going to do kind of the same thing we did on the other one, on the other page. We're taking this to the next level. We're showing a rectangular array. It's still got 3 down the sides. So I'm splitting this into 3 equal pieces, because this is still 3. And I still have 2 pieces on this side. There's my plus 2. But this over here now, we don't know what this is. This is x. I want you to notice something though. So if I take this 3 and I'm multiplying it by 3 plus 2, I have 1, 2, 3, 4, 5 boxes times 1, 2, 3 boxes. So my area for this array is 15. On this array for 3 times the sum of x and 2, I've got this one box that equals whatever x is, this box that equals whatever x is, and this box that equals whatever x is. So my area of this, I have 1, 2, 3 boxes that I don't know what they are. So I have 3 x's, and then I have 1, 2, 3, 4, 5, 6, or 3 times 2 boxes that I do know what those are, that equals 6 total. Okay. And what we just represented with this array here is the distributive property. And we worked on this quite a bit this last week, studying and remembering and reviewing our memory on the distributive property. The distributive property says that when we have any expression in this format, where we have one number being multiplied by the sum of 2 other numbers, that we could rewrite it as an equivalent expression that's that one number multiplied by the first number in our parenthesis, plus the one number on the outside, multiplied it by the second number in the parenthesis. I'm going to write this as a sample with real numbers, because I know that whenever variables are used to show us these formulas or these rules, it's really difficult to tell when they're formulas. So let's write this out in numbers. If I had 7 plus the sum of 2 and 3, I could rewrite this as 7 times 2 plus 7 times 3, or 14 plus 21. So 7 times the sum of 2 and 3, I could rewrite, is going to be the same as 7 times 2 plus 7 times 3. And so let's try that to see if that really is the case. So I've got 7 times, so 2 plus 3 is 5. And 7 times 5 is 35. And then 14 plus 1, is that also 35? Well, 110 plus 2 more is 30. 4 and 1 is 5. So yes, that is the same. Okay. On your first exercise here, you're using this idea to show the area. So you are going to write in the boxes what 11 times 16 is. So you need to multiply. Think of it like a multiplication table. You're finding the area of this box because this box right here, or this rectangle, is 16 units wide by 11 tall. Yes, you may use a calculator to calculate 16 times 11, or you may do it by hand. That is up to you. 16 times 11, and you're going to place the value there. This rectangle, this smaller one, is 11 times 5, and you're placing the value there. I'm not going to do that with you on here because I feel like you can do that. That's an exercise, not an example for me to do. So pause the video, go ahead and do that, calculate it out with a calculator if you need to, and then let's move on to example 2. Okay. On example 2, we're drawing tape diagrams to represent each expression. You'll notice that there's no numbers anymore on this. There's no numbers because we're moving beyond just using numbers. Sometimes we don't know the value yet, and so we represent it with a variable. So I'm going to choose a size. I've got x plus y, or the sum of x and y, and this plus the sum of x and y plus the sum of x and y. So I'm going to draw myself a tape diagram to represent this. So I've got one, two, three different things here, so I'm going to draw 3 rectangles that are about the same size. My goal is to get them as close to perfect as I can, but I am not perfect. And then I'm going to make my x to be this bigger one, and then there's my y, and then in this box here, I need to split it up. And to exactly see my y, I tried to make it exactly the same size because it's representing the same exact number here. We don't know what that number is. And then my x and my y, and I tried to make all my y's exactly the same size, all my x's exactly the same size, because that variable is representing exactly the same number each time. So that is a tape diagram to represent all of my x's and all of my y's. So how many x's did I end up with? So this is x plus y. This is x plus y. And this is x plus y. And total, when I added all those up, I ended up with 1, 2, 3 x's. And I have 1, 2, 3 y's. So I could rewrite this as 3 x's plus 3 y's. Now I have my problem written a different way. I have the 3 x's. I have the sum of 3 x's, or x plus x plus x, and y plus y plus y. So we're writing a tape diagram to show this. And I'm going to try to draw my boxes of the x's to be the same size as the boxes up there. So this is x plus x plus x. And then I'm adding that to y plus y plus y. So I have x, x, and x, y, y, and y. So this ended up being 3 x's, and this is 3 y's. And you'll see, it's the same exact thing. It's just rearranged. It's just put in a different format. So we still have the same exact elements. I tried to make these as close as I could to being exactly the same length because they really are the same thing. It's just organized in a different way, just like Lego bricks that you put together in a different format. And this next one here, we have 3x plus 3y. Think of this. We've really got the same exact thing as what's right above it. I'm really trying to draw that as close as I can to the ones right above it. We have our x, x, x. We have our y, y, y. And they are the same. I mean, I could have just labeled that box without the lines in it, 3x and 3y. I could have just left this alone and wrote that this was x plus x plus x, and this is y plus y plus y. So I kind of jumped ahead a little to what this one was. And then we have one last way that we're going to represent this in a tape diagram. Again, I'm trying to make my tape diagrams look very similar in length because they're really all representing the same exact amounts. And today it may seem like you're doing an art lesson instead of a math lesson. And this, we've got 3 x plus y's. And you know what? You know what I want to do on this one? I really want to show, I'm going to ignore this for a second. I'm going to draw this in a different way. I've got x plus y, and then I've got x plus y, and then I've got x plus y. So this is 3 x plus y's. Got 3 of them. 1, 2, 3. All of these expressions represent the same thing. And when we start solving equations, it's often about trying to figure out the best way to represent the expression, to get to the solution, to figure out what does this x stand for, what number is hiding behind that letter, what does this y stand for. This is not a letter of the alphabet in the same way as you're writing a word and using letters. These letters are here because they're just stand-ins for whatever number we don't know yet. I could very well use a question mark here instead, but it would get really confusing if question marks were worth different amounts. Okay. Example 3 is going to be the last example that we do today. So this is on your next page. And then I'm going to have you do exercise 2 independently, which goes on to 2 different pages, and then we'll pick up with exercise 4, example 4 tomorrow. Find an equivalent expression by modeling with a rectangular array and applying the distributive property to the expression 5 times the sum of 8x plus 3. So rectangular array. So I'm going to draw my rectangle. And on one side, I have 5 units. So I'm going to split this into 5 units. 1, 2, 3, 4, and 5. Wow, I can't believe I got those so even. And then on the other side, I have 8 x's plus 3. So I'm going to start from this side and do my 3 first. So there's my 3. And this side is my 5. I should have made this a little bit bigger because now my x's are going to be super tiny, but whatever. I need to break this into 8 boxes. Remember, these are not 1s though, these are x's now. I want you to picture so this is 8 x's, y's. I want you to picture each of these as an x. And each of these is a 1. So just picture that these are x's all the way down. These are all x's. So some number that we don't know yet. You do not have to draw all these x's in unless you really want to hit it home exactly what each of these boxes represents. Since the x's in the 1 boxes, I should have drawn this rectangle a little bit bigger so you could really see the difference. Okay, so these are the 8 x's. What I really should have put inside here is I've got 1, 2, 3, 4, 5, 6, 7, 8 x's by 1, 2, 3, 4, 5 x's. So this whole thing in here represents 40. 8 times 5, this is 40 x's that we've got in here. So we have 40 x's. And then we have 1, 2, 3 ones times 1, 2, 3, 4, 5 ones. So we have 40 x's plus 5 is another way that we could write that. I want to also draw another image next to it. If I hadn't been trying to fill in the gaps, rectangular arrays do not have to be quite so complex. Most of the time when I'm doing a rectangular array like this, I'm just going to write my 5 over here, draw my line here, write my 3 and my 8x here, and then I'm going to say 5 times 8 is 40 x's. And I'm going to write it in the box to show it. And 5 times 3 is 15. Oh goodness, and here I am. I didn't get my 1 in there. 5 times 3 is 15. Okay? So I usually draw my rectangular arrays like this, and it helps me keep track of what I'm doing. And when I first started learning the distributive property, I used these rectangles a lot to really wrap my brain around what it meant. I don't know what this x is. This x could be the number 5. Probably not, because there's a 5 over here. Could be the number 4. Could be the number 2. We don't know yet, and we don't have an equation, so we're not solving it yet. Okay, kiddos, go ahead and try to do exercise 2 independently, using what we've done here. And exercise 2 goes all the way down here to C and D. And then example 4, we will pick up tomorrow on Tuesday. And that'll be Tuesday, 11/9/21. Okay. I miss you guys. Hopefully I'll get to talk to a lot of you on the phone today. And if you need me, do not hesitate to reach out and call. Have an awesome rest of your day.